Hello, Rockbridge Pre-Calc. Remember how I said I didn't like the word problem in the notes? So I've chosen another one. This is number 26 from the book, and I'm doing this one to help you figure out how we're going to do this in the future. The next section, which is linear programming, which we'll be doing for a couple days, uses this stuff over and over and over again. So I want you to get some practice at doing it. You can't just skip the word problems. Very soon it will all be word problems. So number 26, Christine's Butter Cookies sells large and small tins. They can sell at most 200 tins per day. That's an important point. I'm going to need that as an inequality. It talks about how much butter they use, 2 pounds per large tin, 1 pound per small tin, and they can't use more than 300, so that's an important point. And their profit will be $6 per large tin, $4.80 per small tin. They want to maximize the profit. I did this problem once already, but I made a kind of stupid mistake in graphing, so I'm going to do it again. So I'm going to write my inequalities. First, I know that they can make at most 200 tins per day. So if I take x, that's the number of large tins, plus y, so the number of small tins, so you can see this, that can't be any more than, so it could be less than or equal to 200. So this is, there's a maximum number they can make. Now, talking about the butter, 2 pounds times the number of large tins they make, plus 1 pound times the number of small tins they make, can't add up to more than 300 pounds. That's what all of this says. So that's my next inequality. That's only 2, and that's not enough for a polygonal convex set. So I'm also going to make what I call the real-world constraints, which is they're not going to make negative tins. So x has to be positive or 0, and y has to be positive or 0, and I'll call that real world. So that, with 4 inequalities, that is enough to graph it. I'll solve these for y. Y is less than or equal to negative x plus 200. Y is less than or equal to negative 2x plus 300. And then I'll sketch the graph. So, you know how neat my graphs are. 100, 200, 300, 100, 200, 300. I encourage you to be neater than I am and use actual graph paper, but I'm a little messy. So this line starts at 200, has a slope of -1, so we'll also have an x-intercept of 200. I only want positive x and y, so I'll be in quadrant 1. And finally, starting at 300, slope of -2 means a y-intercept of, an x-intercept of 150. And I need to be below that line. So here's my polygonal convex set. Next, we'll figure out the corners. 0, 0, 0, 200. It's this one. This is 150, 0. To find this intersection, you can use your calculator if you want to graph them and ask it for the intersection, or you can find out where negative x plus 200 and negative 2x plus 300 are the same, and that'll give you the x value where they overlap. That's 100. If I plug that back into either one of my originals, that's also 100, so that gives me y. So my overlapping point is 100, 100. Last step is to evaluate my profit at each of those points, 6x plus 480y. So for 0, 0, 6 times 0 plus 4.8 times 0 is still 0. She makes no profit. They make no profit, excuse me. 0, 200. So what if they sell 200 small tins? 6 times 0 plus $4.80 times 200 equals 960. Okay, so $960 if they sell 200 small tins. 150 large tins, 6 times 150 plus 4.8 times 0 equals $900. And finally, 100, if they sell 100 large tins and 100 small tins, that gives us $600 plus $480, which is $1,080. So, maximum profit of $1,080 come from selling 100 large, 100 small. I hope that gives you an example to help you with your homework, and we will discuss the linear programming in more detail tomorrow.